Hello and welcome to Chapter 5. Let's walk through some of the mathematics on page 118 and 19 so that you and I can both be talking the same language. I've recreated some of that mathematics here in this file, in this screenshot, and I would like to read it to you first off so that you can hear it, and then I want to describe it. Starting out here with this thing, it's called an objective function. The objective function says I am going to minimize the sum as I goes from 1 to n of f sub I times y sub I plus the sum as I goes from 1 to m of the sum as j goes from 1 to m of c sub I j x sub I j. That's how you read it. Let's give it some translation. Minimize is a verb, just like in English, and it's telling me to do something active, some sort of an action. So what exactly am I doing? I am trying to minimize, in this particular example, costs. Fixed costs, that's that first sum, and variable costs, that's this second double sum. What are these sigmas? Sigma is a shorthand way of saying add a bunch of stuff up. Well, how do I figure out what I'm supposed to add up? Well, see, that's what this index is trying to tell me. The index says start at object number 1 and go up at increments of 1 until I reach the last object. For us, the index I is an object that is a plant or a facility, something that we are trying to decide whether to build or not. So the statement here says add up the fixed costs from each potential plant and then move on over here to the variable costs. These are variable costs. This double sum says I have to have the variable cost, the per unit cost, at each plant of shipping product from that plant to each market. I is the plant location, J is indexing the market location. So let me try saying that one more time. I is indexing the plant location, J is indexing the market, the demand location. C sub I j is the cost per unit of producing in facility I and shipping to market J. X sub I j, on the other hand, is a choice variable. So it's actually the first of our alphabet soup here. X sub I j is the first thing that's not a constant. X sub I j is what we are going to try to figure out. It is how much should I produce at facility I and ship to market J. So X sub I j really is the object that we are trying to decide how much. So once again, objective function, minimizing costs. That's what this whole phrase says. Minimize fixed costs plus variable costs. These objects down here that follow the subject to phrase, these objects down here are called constraints. And the constraints, I mean, it looks like there are just 4 objects, but there's actually much more here. These expressions, there are m of them. There is one of these expressions for each market J. So from market 1, market 2, market 3, so on and so forth, to market J. And what this phrase says is all of the production that I send from plant I to market J has to equal or satisfy the demand in market J. So what this constraint is really telling me is I need to make sure I have enough product at each market. And the product comes from my production. Now, this phrase right here is slightly different. This is more about production. K sub I, that's the capacity at production facility I. And I am going to have one of these objects, so there's not just one of them, there are actually n of them. There is one for each production facility. And this says my production, which gets shipped to each of my markets from facility I, cannot exceed the capacity of facility I. That's actually a fairly simple idea. I can't produce more than my building will allow me to produce. So the equation is saying is saying that same thing, but in math language. This object down here we don't see a whole lot except in programming, and since we're going to use Excel I have to have it. This is called a binary variable. This each y sub I, so I is for each particular plant. Y sub I is going to take either a value of 0 or a value of 1. And if you think about it, here's what it's telling me. If y sub I were to be 0, that would mean we're not producing anything in plant 0. We just said, not that plant, that's not what we're going to use. If it's 1, then we are producing at plant I. This last constraint down here is called a non-negativity constraint. And there's a lot of these. It looks like one expression. No, there are m times n of these expressions. And what it does is it guarantees us that we are not saying stuff like, I'm going to produce a negative amount of output somewhere. Because, negative amounts of output don't make any sense. At least they don't in my world. So hopefully they won't in your world either. So this is kind of a overview of what this math says. What I'm going to do is I'm going to terminate this video. Hopefully you can come back to it if you want. And then I'm going to move on to an Excel spreadsheet where we can take the equations here. We're going to apply them to problem on page 118 through 121. And I'm going to show you how to put them into Excel and then how to get Excel to do some work for you.